Hi. The question says that a communication is launched 42,000 kilometer above the earth. Okay. So above the earth means from earth's surface 42,000 kilometer. Okay. So we will write above the earth's surface and we will consider it as h. Okay. So now we have to find out the orbital speed of this. So for that, first we will draw a sphere that will be considered as the earth. So this is the earth and this is the center of the earth O, and the mass of the earth is considered as me. Okay, and this will be the earth's surface, and O to this point, that is from earth's surface to the center of the earth, it will be considered as the radius of the earth, that is RE. Understood? Now see what we have to do. We have to consider a certain height, that h is equal to 42,000 kilometer. That means the communication is launched above earth's surface at 42,000 kilometer height. So we will consider a certain point, suppose P, that is at h height above 42,000 kilometer, that is from earth's surface. So what is the total distance from the center? So total distance from the center of earth, that is O, is equal to RE plus H. Clear? Now what is this orbital speed? Suppose the communication is at point P and it is having speed O. Clear? Like this. So it's a orbit. We can consider it as an orbit, and at this orbit, suppose the speed is VO. For that, there is an object, right, at this point, okay, or at point P, if we consider it as an object, or we can consider it as a satellite also, we can consider. So the satellite is suppose at point P like this, and it is moving in this circular orbit like this. Okay, so at each and every point its direction will change. Okay, and the force that will be directed towards the center, it will be the centripetal force, and it will be equal to mv square by re plus h, because it will be directed towards the center of the earth like this, towards the center of the earth. When generally we know when an object is moving in circular motion, okay, around a circle, the centripetal force always acts towards the center of the circle. The same thing is happening over here also. The object, the satellite, is moving in this circular orbit, okay, and what will be the direction of the centripetal force towards the center? Okay, that will be equal to the gravitational force, that is the gravitational force between the earth and the satellite and the object, we can say. So me will be the mass of earth and small m will be the mass of the satellite or the communication, whatever, and the distance square will be re plus h whole square. So like this we can equate. So now from this v is the orbital speed, VO. Okay, the speed with which the communication, the satellite, is moving in circular orbit. So this centripetal force must be equal to the gravitational force. Okay, so we can see that from this equation we are getting V0 square is equal to GME by RE plus H. Okay, now we have to simplify this equation. So V0 is equal to under root G M E by R E plus H. And as we can see that the orbital speed depends on the mass of the earth. It will not depend on the mass of the communication or any other object that is moving. Only it will depend on the mass of the earth and the distance from the center. Okay, so as we know, capital G is 6.67 into 10 to the power minus 11. Mass of earth is 6 into 10 to the power 24. These values we have to keep in our mind. All time these values will not be mentioned in question. Okay. What will be the radius of the earth? 6.4 into 10 to the power 6, the radius of earth. And what will be the height? See, the height is 42,000 kilometers. So we have to convert it into meters. So 42 into 10 cube kilometer, already it is there, into 10 cube again for to convert into meter. Okay. So then under root. So now we have to simplify this value. The answer is 2.8775 into 10 cube meter per second. So this is the required orbital speed of this communication. Okay. This is the answer of this question. So the concept what we have to use in this question, that is the centripetal force, the concept of the gravitational force, and the formula of the orbital speed. Okay. So I hope you understand the solution and the concept well. Thank you. All the best.